Okay, now this question number 3, 4, 5, and 6, they are exactly same questions. Okay, and remember, they are the one of the most important question, because this type of a question you will find in each and every question paper for 5 marks. Okay, so I don't know why the same question or same type of a question is coming again and again in every question paper, but yes, if you see the last 4 5 years question paper, you will find this question, this type of a question in each and every question paper. It is for 5 marks there. So let me see what is this question. First part of the question is show that this vector field f bar is a conservative, and the second part is we have to find a scalar function phi which satisfies the condition f bar equal to del phi. So question is divided in two part. The first part, yes, our aim is to prove the vector f bar is a conservative. Yes, what is the condition to prove this vector f bar as a conservative field? What is the criteria, or what is a mathematical formula which proves that this field is a conservative field? There is one parallel word for conservative, is a irrotational field. The field is a conservative or irrotational if and only if. Yes,
Curl F is equal to 0.
very good.
The gradient cross
Oh,
F bar should
very good. Curl of vector f bar should be 0. So let me see the first part. Uh, Consider curl f bar. Curl f bar, that is a del cross f bar, and we already seen this curl f bar is a determinant whose first row is the unit vectors I, j, and k. Second row are the components of this del operator, which are dou by dou x, dou by dou y, and dou by dou z. And third row is the components of vector f bar. So here, this is our f1. The f1 is a y square cos x plus z square, that is f1. F2 is a 2y sin x, and what about f3? F3 is a 2xz. Okay, so that about the determinant which we have to expand now. So let me expand it along the first row. So I cap into its minor. Now we have to evaluate this 2 by 2 determinant here, which is a derivative of this f2, sorry, f3 with y minus f2 with z. Yes, anyone? What should be?
It will be 0.
Remember,
It will be 0.
this is the common thing that many of the students do in the exam. Question is always that is a show that it is a conservative or irrotational. So definitely we are getting each bracket 0. We know the vector is a 0 if and only if its all components are 0. So some students write I cap into 0 plus j cap into 0 plus k cap into 0 and is equal to 0 bar without any calculation. But some of the examiner generally are interested to see this main step where you return the partial derivatives. It's not like all. The majority of the times you get the marks for writing directly that 0 bar also, but don't take a chance. You should do a calculation. So derivative of f3 with y is a 2z, is that? And then you can write minus 2z because that should come. You'll observe this f2 with a, sorry, my mistake.
No, sir, it will be directly 0 only.
Directly 0 minus 0.
Oh, yes, directly 0 because derivative of f2 is this 0 minus 0. My mistake. Okay, I cleared everything. Let I check. Yeah, there is a chance. Just a minute. So this is 0 minus 0. That's okay. Minus j cap.
2z minus 2z.
2z
Yes, now
minus
it is a
2z.
2z minus 2z and plus k cap
2y cos x minus 2y cos x.
2y cos x minus 2y cos x. And this happens always because the question is show that it is a conservative. So each and every component goes a 0 and we get the answer as a 0 bar. This implies uh, this f bar is conservative or irrotational. Okay, so that is the end of the first part of the question, which is always a very simple. Generally this part have the 2 marks out of 5 and the remaining 3 marks is generally given for finding that scalar function phi. Okay, the remaining 3 marks are for the second part generally given. So once you finish this part, tell me, we'll move to the second part of the question.
Sir, finished.
Okay, very good. So the second part now, part 2, find find the scalar function phi such that f bar equal to del phi. So this is the second part. Okay, now there are two methods to find this scalar function phi which satisfies that f bar equal to del phi. Method 1, I will say it is a shortcut method, and method 2 is little integrations we have to do it. Okay, method 1, yes, you have to remember a formula. Method 2, you don't have to remember any formula. So that is the difference in the two methods. So whatever the method you think simple, will continue in the remaining questions there. So first method I will say here, method 1, method number 1. In the exam you have to do it only by one of the method. Our aim is to find the function f bar equal to del phi. Then there is a shortcut formula to get such a function phi. Phi is equal to integration of f1 dx with treating y and z equal to constant. So this formula is already given on the slide of that property 3 of curl f bar, that given there. So if you can write it here also, phi is equal to integration of f1. This is our f1. Integrate the f1 with respect to x, treating y and z like a constant. That is the first term, plus integration of terms. I will write it in short. Terms free from x, terms free from x of f2 dy, treating z as a constant. Now first thing I want to tell you, how many terms are there in f1? Yes, anyone? How many terms are there?
One. Two
No,
terms.
there are two terms.
Term.
Terms are separated by addition and subtraction. Okay, so y square cos x is one term and z square is the second term. So there are two terms that in f1, but f1 we have to keep as it is. There is no problem there. Now we have to take only those terms of f2 which are free from x. How many terms are in f2 first?
One.
There is only
Only
one
one.
term. 2y sin x is considered as a single term because in multiplication, and that involves the variable x. Sin x is there, so this f2 term is not a free from x. So what should be written here? 0. Nothing is there. No term which is free from x of f2, so 0 dy, that will come in the next step, uh, plus integration of terms free from x and y, of f3 dz. Now how many terms are in the f3 there?
Sir, one.
One.
Again only one. 2xz is a single term. Is it a free from x and y?
No, sir.
No, there x is a present. So again here comes a 0 there. That's one. Okay. So here yz is a constant, here z is a constant, and here nothing is a constant, because when we say terms free from xy of f3, only the terms of z will appear here to integrate with z. Okay. So that will be the shortcut formula. Now this formula you have to by heart. If you have to use a shortcut method, the task is to remember this formula. Okay, and once you use this formula, you will write now integration of f1. So f1 is here, y square cos x, plus z square dx, treating y and z as a constant, plus integration of 0 dy and integration of 0 dz. Yes, in many places some authors are writing plus c as a constant of integration also, and in some places that is not written. So choice is your. If you write plus c, that is also correct. Without plus c, many times it is considered correct again. So it is a more general solution with a plus c there. So what will be the integration of the final answer?
Y square sin x plus z square x.
Very good. Y square sin x, integration of cos x is a sin x, and integration of z square is a z square x. Integration of 0 dy is a 0. Integration of 0 dz is a 0 plus c if you want. Yeah, that is the final answer. This is the required function, and you will cross check. If you cross check, if you calculate the gradient of this function phi, if you calculate del phi, you will get this f bar. You will get f bar, provided this f bar is nothing but it is a del phi. It is a del of phi, gradient of that function phi. So you can cross check if you want. Calculate dou phi by dou x, you will get f1. Calculate dou phi by dou y, you get f2, and dou phi by dou z, you will get f3. That's one. So this is one of the simple method where you have to remember a formula. I will show you the second method that is also simple, and there is no need to remember any formula for second method, but little extra calculation we have to do it there. Any doubt?
No, sir.
Okay.
Sir, you have to
And are
copy,
you
sir.
completed? Are you completed
No
this?
doubt, sir.
No, sir.
No, whether
Maybe
you
1 minute.
completed?
Right.
Yes, sir, completed.
Okay. So
No, sir.
okay,
Sir,
just 1 minute I will give you. Yeah, completed.
No, sir. Sir,
Done?
wait 1 minute.
There are two groups. Few are not completed, few are completed. Okay.
Sir, done, sir.
Done. Okay, very good. Now let me move to the method 2. So this method 2, method 2 not require any formula. See what we have to, we want phi such that we want f bar is equal to del phi. Okay, we want a function phi which satisfy this condition, f bar equal to del phi. That is nothing but f1 I cap plus f2 j cap plus f3 k cap is equal to del phi means dou phi by dou x I cap plus dou phi by dou y j cap plus dou pi by dou z k cap. So here we are saying we want a function phi which satisfy this condition f bar equal to del phi, means indirectly equating these two vector we are saying we want a function phi whose dou phi by dou x is coming equal to f1, dou phi by dou y should equal to f2, and dou phi by dou z should be equal to f3, and that we are going to write it here only. Dou phi by dou x should come equal to f1, just a minute. Dou phi by dou y should come equal to f2, and dou phi by dou z should come equal to f3. What is f1? F1 is here, y square cos x plus z square. What is f2? F2 is a 2y sin x. And what is f3? F3 is a 2xz. What should be the next step to get a function phi then?
Integration, both
Yes,
the side.
Sir,
integration. Very good.
integration.
So let we integrate this equation number 1, this first equation with respect to x. Integrating with respect to x. So tell me what should be the value of function phi? What is the integration of y square cos x with respect to x?
Y square sin
Sir,
x
y
plus
square
x
sin
plus.
x plus
Y
z
square
square x.
sin x plus z square x. Only
Plus c.
Plus c.
plus c. Now here you are making little mistake. Yes, plus c is okay if you are in ordinary integration. You are integrating partial equation, partial differential equation. So when you integrate partial equation, if you are integrating with x, the constant is not only c, it is a function of other two variable. So I will say here plus f1 f1 of yz. Now why this f1 of yz, again I will explain. So let you differentiate this with respect to x. Let you differentiate this phi with respect to x. Dou phi by dou x is equal to y square cos x plus z square plus derivative of f1 of yz with respect to x is 0. So this is a constant. This is a constant when you integrate with respect to x. This is actually a general solution. when you integrate a partial equation. So that is only the difference. Now this is only the change, and now you will get the answers. Let you integrate second with respect to y. Yes, what should be function phi?
Y square sin
Y
x.
square cos x.
Y square sin x, not cos x, because you are integrating with y now. So this is a y square by 2, 2 gets cancelled, y square sin x plus
fx.
function
F
of
of x.
x z. Okay, third,
Z square.
not z square, it is xz square plus
F of x y.
xy. Very good. Now we are getting these three functions. Actually, these three functions are such that whose dou phi by dou x is f1, dou phi by dou y is f2, and dou phi by dou z is f3. But these are three different functions right now. We have to write only one function which satisfy all these three conditions. And how we get that function? You can consider any one of that as a answer where you have to determine the value of this constant. We are saying for third equation f3 of xy is a constant. So you get this constant by comparing this equation only. If you compare this last equation with the first, you will observe xz square is as it is, and what is the function of xy left in equation 1? That is y square sin x. So if you replace f3 of xy by y square sin x, you get the answer. Not only that, if you compare second with the first, y square sin x as it is, and function of xz we left as xz square. So if you replace that, get us complete solution. Now if you go reverse way, suppose you start with the first and you are comparing that with the say second. First you are comparing with second, so you are getting this one and you are looking for function of yz in second. But you observe there is not a single term which contains only y and z together. Y and z is not together, so function f1 of yz is 0. So you can get unique answer by comparison, or I will give you a simple rule to write the final answer, and that rule says write all possible terms in first, second, and third function phi without repetition. Like xz square is there, this is xz square, don't write it two times, write only once. Y square sin x is there, y square sin x is there, write it only once, and that's one. So thus we can say phi is equal to y square sin x plus z square x plus the constant of integration. You can write it because here is again plus c, you can write it everywhere. Okay, so that c you can take it here, and we got that as answer. So phi is equal to y square sin x plus z square x plus c, where c is that constant of integration again. So that about the second method. Now if you have the doubt, yes, you can ask.
Sir,
Yes.
so I didn't get the how we compare three equations, sir. Will you please tell again?
So again, I'm saying the same thing. If you want to compare, you have to just find out the constant of integration. So for equation number 1, the constant of integration is f1 of yz. Now look for the term of only y and z. Is there any term of function of yz here? Only y and z
No.
together? No.
No.
Is there a function of yz here anywhere? No. So
No, sir.
function of yz is a 0, and that becomes your answer. Okay. By chance, if you
Okay.
start with third, by chance suppose you start with a third, and now you are looking for function of xy in other two. So function of xy is here,
Yes.
y square sin x, and that is y square sin x. So this become a constant of integration here, and you get the same answer, no? If you replace here y square sin x and xz square, that is the same. So that way actually you are writing. Okay.
Yes, sir. Yes, I got it, sir.
Okay, or simple thing, write all possible terms without repetition. That's the other way. So both the methods are simple. Choice is your. You can do it by any of the way. Answer will be the same. You can't say that I done it by other method and I got a different answer. It will not happen. So are you completed?
No, sir, 1 minute.
Okay, okay. I'm not writing some lines here. Like after this, you can write here integrating with respect to x. Then only you get this equation. Integrating this with respect to y, you get a second equation. Integrating with respect to z, you get a third equation. So later on, you should know what is done there.
Done, sir.
Done. Okay, very good. Now we'll move to this question number 3. Okay. So so it is similar question now. I told question 3, 4, 5, and 6. They are exactly similar. Only a small change in the functions there. Or here is a little different question, question 3, where some constants are introduced, and we are asked that find the values of this constant a, b, c, so that f bar is a irrotational vector. So obviously we should start with a del cross f bar is equal to 0, and we can find the values of a, b, c first. And the second part is the same. Determine the function phi such that f bar equal to del phi. So again, the question is divided in two parts. So step 1. Right now in this question, f bar is irrotational given. That's a given. It is irrotational. It is a given there. Consider or given del cross f bar is a 0 vector. That's a given. So this gives us a determinant. First row, yes, I, j, and k. Second row, the operators dou by dou x, dou by dou y, and dou by dou z. Third row, f1 x plus 2y plus az, f2 bx minus 3y minus z, and f3 4x plus cy plus 2z, and that should be a 0 vector. Now you should tell me the derivatives here. So this is I cap into,
C minus 1.
yes, c, derivative of f3 with y is a c, f2 with a z, it is a minus minus plus 1. Derivative of f3 with x, it's a 4. f1 with a z, minus a plus k cap. Derivative of f2 with x, it is a b, and derivative of f1 with y. Yes, what should be the next step? This vector should be a 0 vector only if each component should be 0. So we get c plus 1 is a 0, 4 minus a is a 0. Ignoring the sign, if you can take minus of 4 minus a is also 0, it doesn't matter. And b minus 2 is a 0. And this gives the values for a, b, c. So a becomes 4, b becomes 2, and c becomes minus 1. So 4, 2, minus 1 is the value of, or are the values of a, b, c. 4, 2, minus 1. That about the first part of the question. We completed, or we obtained the values of ABC for which this vector f bar is irrotational. That's one. So, are you completed?
Please wait.
Yes, yes, I will wait. Wait for two.
Yes, sir. Done.
Okay.
No, sir, wait.
Yeah, okay.
Yes, sir, done. Thank you so much.
Okay, okay, good. No issue. So you can try the second part now. The method you think simple, you can start that way, and you can find the function phi which satisfies this condition f bar equal to del phi. Already we observed the value of a is a 4, value of b is a 2, and value of c is a -1. So replace that values of a, b, c, and then you can find the function phi. So which method you want? Shortcut method or lengthy?
The first one.
Method
Sir,
1.
shortcut.
Okay. Okay, yes, means first method, yeah. That is method 1, it is by formula only. So you can say step 2 for solution. Step 2 to obtain phi such that bar is equal to del phi. So you can say phi equal to. First, always, if you want to use second method, don't forget to write the formula. Without formula, you should not proceed. F1 dx, treating yz as a constant. Integration of terms free from x of f2 dy, treating z as a constant, plus integration terms free from xy of f3 dz. Okay, so here is z is a constant and here is yz is a constant. So phi equal to, yes, what is f1?
Sir, x square by 2
X
plus
plus
2yz.
2y, value of a is 4, na? And here treating yz as a constant. Just tell me those terms which are free from x of f2.
Minus 3y.
Minus z.
Minus 3y minus z, correct? Minus 3y and minus z. There are three terms actually. In f1 there are three terms, f2 also three terms, dy. But here z we have to treat like a constant. And lastly, how many terms are in f3? Again three.
Minus Z.
Uh,
Minus Z.
not minus z. Here 2z will left.
Sir.
It's a 2z. Na? In f3, the terms free from xy of f3 is a 2z only. So that about the replacement of f1, f2, f3. And last step now, integration. So integration of x with respect to x is x square by 2. Integration of 2y with respect to x is 2yx. Integration of 4z with respect to x is 4zx. Integration of minus 3y with y is a minus 3y square by 2. Integration of minus z is a minus zy, and lastly z square, and that is the final answer. Plus c if you want, yeah, you can write it, that is also correct. That is the end of the question then.
Sir, I have a doubt, sir.
Yes,
Sir, in the first term, we have to keep y and z constant.
correct.
The second term, we have to keep z constant.
Yes,
And in the third term, we have to keep nothing constant.
because it is already written terms free from xy of f3. When you write the terms which are free from xy of f3, you get only function of z there na, in the bracket, like this. Are you getting?
Okay.
So if one of the terms have x or y, we are ignoring that term. So obviously there is no need to treat anything as a constant.
Okay, sir. Thank you.
And here in second, actually we are taking terms free from x of f2. So there is no x term, only yz will be there in the bracket. So we have to treat that z as a constant. That way.
Sir, I have a small doubt.
Yes.
Sir, in the second last step, can I integrate without writing y comma z equals to c and z equals to c in the beginning?
This one, this is in the bottom, this part.
Yes, sir.
You have to write it, na. That is only the meaning. That is only the shortcut formula. Otherwise, how examiner come to know that how you integrated it? Because there is nothing like partial integration. When you write dou phi by dou x, yes, that it itself indicates you have to partially differentiate. Okay, so there is no notation for partial integration. So it is just like a partial integration notation. Yz as a c. So this notation itself indicate you treated them as a constant. Otherwise, uh, it depends on examiner to examiner again. He may deduct mark, may not. Okay. Sometimes you got the final answer, and by looking the final answer, you get full marks there. And some examiner doesn't look any of these small things there. But you should not write incorrect things, or I will say you should write mathematically correct things there. So write the formula completely. Is there any doubt other than this?
No, sir, no doubt.